Hello students, today we are going to discuss about Kronig Penney model. According to Kronig Penney model, the potential energy of the electron has the form of a periodic array of square well, which means that the potential energy of the electron is not a constant or zero, it varies as periodic square well. A periodic potential well is shown in the figure. Here, red region indicate the potential well and blue region represent the potential barrier. Consider a potential well of length 0 to a, and potential barrier of length -b to 0. Let consider potential well as region 1, and potential barrier as region 2. Wave function of potential well is psi1, and potential barrier is psi2. The potential in the potential well is 0, and potential in the potential barrier is V0. That is, potential energy is show maximum value in the region 2. The potential energy assumed to be 0 in the region 1. Region 2 can be represented as -b less than x less than 0. Region 1 can be represented as 0 less than x less than a. Schrödinger wave equation for two regions are let assume substituting equation 3 in equation 2. Where alpha and beta are two real quantities, according to Bloch theorem, the solution of Schrödinger equation for electrons can be represented by a periodic function u, x, as wave function for first region can be written as taking the first derivative, using product rule, can be written as taking the second derivative, using product rule, can be written as since I square equal to -1. Then, dividing throughout by e raised to ikx. That is, similarly, substituting equation 5 in equation 1. Substituting equation 5 in equation 4. We know that Dividing equation 7 throughout by e raised to ikx. We know that substituting equation 6 in equation 4, and using the similar methods, we get general solution of equation 10 and 9. Determine the values of a, b, c and d. We use the boundary conditions. Here u1, u2 and their first derivatives are continues, which means that u1 equal to u2. First derivative of u1 and u2 are equal. Using this boundary condition we get 4 equations. Represent these equation j, in the form of a determinant, and find the solution of determinant. We get the equation as Kronig and Penney considered the probability that v0 tend to infinity, then b is nearly equal to 0. For smaller values of b sin and cos, Vales reduced to substituting, this result in equation 11. Substituting 12 in equation 11, we get this is the condition for the solution of wave equation to exist. Equation 13 is satisfied only those values of alpha a, for which curves lies between lines cos ka equals +1 and cos ka equals -1. Such values of alpha a represent the wave-like solution, and are accessible. The other values of alpha a are inaccessible, hence in this region where the alpha a values are not within 1 or -1 are prohibited and are called forbidden band. Conclusions from Kronig Penney model. The energy spectrum of electron moving under periodic potential consist of alternative regions of allowed energy and forbidden energy. These regions are referred to as the allowed and forbidden energy band. The width of the allowed energy band increases as the value of alpha a increases. When p tend to infinity, the barrier strength increases, thereby electrons are tightly bounded to the solid, the width of the particular allowed band decreases, the allowed region becomes infinitely narrow, and the energy spectrum is a line spectrum. When p tend to infinity, using equation 14, sin alpha a, nearly equal to 0, then we can write as these are energy levels of a particle, in a constant potential box, of atomic dimensions, or, they have discrete energy level. If p equals 0, electron is almost free. Alpha equals k. Then E can be obtained as these are the energy values of completely free particles, for which all energies are allowed, hence the energy spectrum is continuous.